So welcome again to the multimedia course Info 430. Application, a small Matlab application, we will create a new script in which we are going to write our code because it is easier to press here run instead of rewriting every time we have a mistake. So here I am going to write in this script I am equal read the image mandrel dot bmp, and let us run first to see if it will read. He wants me to save the script before running it, and here we go. It is opening the image, which is 512 times 512 times unsigned int 8. So let us see this image. show I am, and we will run again, and we will have our mandrel image of the lecture. So this is our beautiful mandrel, and we know that is an image with 3 channels, which are R, G, and B. So we want to separate these channels. It is easy. So image R is the matrix, that is the submatrix of M, is equal to M, but with the full range in width, full range in height, and the first channel only. Same thing I will do to reproduce MJ, G, and MB. So I will change only here, instead of MR, MG, channel 2, and MB for blue channel is the channel 3. So if I run this code, what will happen? I will have my image variable, but also I have 3 other matrices which are not 3-dimensional, which are 2-dimensional. So each matrix is coded over 8 bits. If I want to see them, I will open figure 2, for example, in order to see my image MR, and the same thing I will do with MG and MB. So I will display simultaneously 4 images on the screen, just like we saw in the lecture. And here is my MB, and I will run the code, and I will move the images so I can see them. So this is the black channel represented as a grayscale image because it is over 8 bits. Whenever Matlab sees a matrix over 8 bits, int 8, so he will suppose that this is a grayscale image. In fact, there is no difference, but we know that this is the red channel, green channel, and blue channel. So let us make a small adjustment to the color map to tell the Matlab that we want to see this in instead of gray level, we want to see it in red level because this is the red channel, and the same for the others. So what I will write here, I will create a custom color map, a custom made color map. A custom color map, I will make a color map special for R, for the red channel, and a special one for the blue, and one for the green. In the one for the R channel, in order to see only the red color, I will provide normal values for the red channel and zeros for the green and blue. So in this case, whenever he wants to show me something, he will show it in only red, and I will repeat this process. So I will create first a vector that goes from 0 to 1, but this will give me only 2 values, 0 and 1. I wanted to have 256 values because my image red is coded over uint 8, so it has 2 to the power 8 values. So I want to go from 0 to 1 with a step which is 1 over 256. So this will give me the vector I want. I will show you an example. Here I have a vector A which is equal from 0 to 10 with a step of 2. I will not put semicolon here in order to see what is A. A is equal 0, 2, 4, 6, 8 and 10. So in the same logic, I created my vector from 0 to 1, V. I will create another vector which is only zeros. So there is the function zeros of one line, 256 column. So I want a vertical vector which is zeros. And back to my command line, I want to show you how to make this vector a vertical vector. So I make A and this sign and the code sign. It is the transpose of A and it will become the vertical vector. So in this way I will make my map of red. Map of red is the vectors V prime with Z prime and again Z prime. And let us try it here. M equal the matrix composed of A prime space A prime, and this is a matrix of 2 columns and 5 and 1, 2, 3, 4, 5, 6 lines. And here I will have a matrix of 3 columns and 256 lines. And then I will show R. Inside here I will say figure 1 to let me, and here I will tell the mshow function that you must show me R, but using my custom made map R. And again I will make a custom made map for the green channel and the blue channel. And here is my custom make. For green I will have zeros and V and zeros, and for blue I will have zeros, zeros and V. And I want you to use here the map G, and here the map especially made for the blue channel. And now I will run my code and I will get an error, and this error is because the dimensions of the matrices are not the same. So I have a mistake here. Of course I have this mistake because I have to divide by 255. So let us run again, and here are our channels. So the same matrix, the same variables, I didn't touch the variables, but I touched the display. I showed you those variables with this trick. Now back to our command line. I will clear everything, and I will go I will also close everything, close all, and I will clear also all the variables, and I have no more variables, and I will clear the command line, and I will go again to my script to show you that I can use, for example, RGB. If I write in the command line RGB2 and then press tab, the Matlab will offer me the set of predefined functions that are transformations from RGB color space to, for example, gray color space, SSV, indexed color space with an custom LUT, lab color space, which is we just saw XYZ, and NTSC color space, which is nothing else than YIQ, XYZ color space, and finally YCBCR, which is very similar to YUV. So let's try YIQ. Now go back to my script and have mandrel. I will modify this script a little bit, so I will remove the command to create a custom command line. I will remove the command to create figures, because over one figure I will subplot, and I will show you how to see the different channels. So first I open image equal mread mandrel. Second, what shall I do? I will transform my image into an image YIQ, which is equal to RGB to NTSC of M. So I get my three-dimensional image. Now I will separate the YIQ channels. So I can use this command, but I change Y is equal MYIQ 1 and I is equal to the second channel and Q is equal to the third channel. And here we have the figure, and I will subplot this figure. So subplot the figure into two lines, two columns, and for the first line show M and not in gray, because this is a three-dimensional image. And then subplot and show Y, and then subplot and show I, and finally subplot and show Q. But every time I have to make attention, this here I want in the second part of the image, third part and fourth part. Let us run first to see what we will have, but we will modify this. So run, and over one image I have the color, the original one, the Y, which is fine, and the I and Q, which are not scaled because they are values, they are doubles, and mshow is used to show us uint8. So mshow is not the right function to use here. We will use instead image sc, which will scale our values to be image sc, which will scale our values in order to be between 0 and 1, only for display purpose. So now you know the difference between the mshow and image. I will add titles for each part of this image, title, and I will provide a string between simple quotes, and here I will write original, and then I will provide the title. Here it will be the Y channel, and here the I channel, and finally the Q channel. And now I will run, and as you can see, our images are just the same that we saw inside our lectures. This is Y, I, and Q, and here are our titles. Again, I can repeat the same experience, but instead of calling Y to NTSC, I can call Y to, as you guessed, RGB to YCBCR, and then here I will write CB. This is a variable name, this will not change anything, but we would like to be perfect, and YCBCR and CB channel and CR channel. Let us finally run this. We have a small mistake. There is no function called YCBCR. What is the name? Small letters. Okay, this is a very minor problem. YCBCR small letters. Run again, and here we have our YCBCR channel and subplotted with the original image. All what you have to do in order to make your homework is to save as, and then you choose the figure JPEG format so that you can save your figure. You give it a name, for example YCBCR channels, and you have your image in your workspace folder. So this is it, and we go back and we see what else is there in the assignment. You have an additional exercise, which is color model transformation, and this one I will edit here in front of you in order so you can solve it. And you have to open again Mandrill and to view the three planes already done here. Already done here in the first exercise. Display the RGB channels, so this is done. So what is left for the last exercise? You have to write your own YIQ. So apply RGB to YUV transform. So write a function RGB to YCBCR. Write your own function. Okay, I know that this exists in Matlab. Write a function that is like this. Let's call it my YRGB to YCBCR and my inverse function to go back YCBCR to RGB, and that reverses a given image as defined in JPEG 2000 from RGB to YCBCR and from YCBCR to RGB. And this is the exercise number 4, and I gave you here the equations. You just write the function and you apply this equation. For example, how I will show you how you write a new function and you say that mout is equal to function which takes function my YCBCR my RGB to YCBCR. I give you an image, you give me mout. How do I calculate mout? Just like I showed you. I copy and paste this code here because we have matrix calculation. So y is equal to r plus 2gb plus 4, all you have to do is to have the YCBCR channels, the YR and YG and B channels. So you take them and you say R channel is equal M of 1, B channel is equal the input image 2, and C channel is equal the input image 3. And now you have to transform them into so M is equal to double of M, because you are making divisions and operations. And then you have M out. The easiest way to make M out is the same dimension as M is to affect it to M. And later when you have your YCBCR, let us put semicolons at the end, you join those channels into one channel. So you say M out of 1 is equal to Y, and M out of 2 is equal to what did we call it? Here we have R, G and B, and here we have CB, and here we have channel 2, and here we have channel 3. So I have my M out now. I can return M out. I don't return it to unsigned int 8 because this is not inside that range. So I leave it like this, because look, it is always double here. And if you give me the image name instead of giving me the image matrix, so the first thing here is to read the image, mRead, and I take the parameter image name to read this image. So this is my function. I will save it. I will save it how? He will propose to me, maybe I should write function first. So save, and now he will propose to me the name of the function, the same thing as I wrote, and I save it. And in order to use this inside my code, I can directly use it. How? Instead of calling RGB to YCBCR, I just call simply my function that I just created. So we have an error, so we click over the error to see what is the problem, and he will tell us that expecting MATLAB expression and 2G is not a MATLAB expression. So we will multiply, we will use the asterisk to multiply, and then we go back to our code and we make sure that our code provides the image name, because our function takes not the matrix but the image name, and we make sure that the image we provide is inside our current folder. So here I am working in a folder special for this lab, and I put Mendrel inside it instead of giving the full path as you already see. And now I will go back to my code and I will try to run it again, and this time I got my RGB, but I have the CB and CR channels equal, so I must have done something wrong. And I will see here what is my problem. I have left this typo here, so now I can save and I can run again, And here are my YCB and CR channels successfully written. So as you saw, it's very easy to do what is the predefined MATLAB functions